Question 24 from Section 1 of the 2019 Higher Physics Examination. A student connects 4 identical light-emitting diodes, LEDs, to a 2-volt DC supply as shown below. Which of the LEDs P, Q, R and S will light? And we're given our usual 5 choices. Now before we start, let's take a look at the basic LED circuit as shown here. Now that LED is given by the symbol of the arrows coming off. The bar part is actually representing the N-type part of the diode. The triangle part represents the P-type part of the diode. Now that LED will light because we say it's forward biased, because the N-type is connected to the negative supply and the P-type is connected to the positive supply. So the LED will light. It's forward biased. Now, if we have this type of circuit here, you can see that the LED is reverse biased. The P-type is connected to the negative supply and the N-type, represented by the bar, is connected to the plus supply. It's reverse biased and it will not light. In fact, it will block the circuit and no current will flow in it. If we look at this type of arrangement here, we can see something strange happening. We can see that the first LED here is in fact correctly biased. The N-type is connected to the negative supply and the P-type is connected all the way around to the positive side of the battery. It's this LED here which causes a problem because it is reverse biased, because the N-type, represented by the bar in the symbol, is connected to the plus type, and the plus part, or the P-type of the semiconductor, is connected to the negative supply. So that is reverse bias and it will not light. And because it is reverse bias, it blocks the rest of the current in the circuit and therefore none of the LEDs light up. Now let's take a look at the circuit in question. LED P, you can see, is reverse biased. That's this diagram here. The N-type is connected to the plus type of the circuit, therefore that's not going to light. If we look at LED Q, you can see that it is forward biased. We can see that the N-type semiconductor is connected, we follow the line, follow the wire, to the negative supply, and the P-type, represented by the arrow or the triangle, is connected to the plus type. So that LED will in fact light up because it's in a parallel branch. If we look at the third parallel branch in that circuit, we can see that we have a similar situation to the last circuit we talked about. LED S is correctly biased, it's forward biased because the bar type is connected to the negative supply, the N-type connected to the negative supply, and the P-type part of the semiconductor, which is the LED, is connected to the plus type. But it's this LED here that is not forward biased. In fact, it's reverse biased because the N-type is connected to the plus type of the battery, and therefore that LED will not light up. And when it doesn't light up, it acts as a block on the current going through this branch, and therefore the LED S will not light. So in essence, only one LED is correctly forward biased in that circuit, and that is LED Q, and LED Q is the only one at the light, and the answer is going to be B. Question 25 of Section 1 of the 2019 Higher Physics Examination. A student makes the following statements about uncertainties. 1. All measurements of physical quantities are liable to uncertainties. 2. Random uncertainties occur when a measurement is repeated and slight variations occur. Statement 3. Systematic uncertainties in a quantity occur when measurements are either all smaller or all larger than the true value of the quantity. Now let's go through each in turn and see which one is correct. Statement 1. All measurements of a physical quantities are liable to uncertainties. Well, that is true. Every measurement we make, there's uncertainties involved in it. Random uncertainties occur when a measurement is repeated and slight variations occur. That is correct as well. Because when you take various measurements, slight changes in the atmosphere, slight changes in the way you look at the experiment, all these things result in each measurement being repeated and slight differences in them. So statement 2 is correct. Statement 3, systematic uncertainties in a quantity occur when measurements are either all smaller or all larger than the true value of the quantity. Now that statement is correct as well. Now what is a systematic uncertainty? Well, that can be explained by looking at this ammeter here. Now if I go and use this ammeter to measure Ohm's law or to measure the value of resistance, the meter is not properly set at 0 amps. It is down at -1, and therefore every measurement I take will be less than the true value of the current. So a systematic uncertainty occurs when our meters are not properly calibrated, or something is wrong with the experiment which is going to give the same sort of uncertainty in each quantity all the time. So systematic uncertainties in a quantity occur when measurements are either all smaller or all larger than the true value of the quantity, and that is correct. So we have 1, 2 and 3 all correct, so our answer must be E in this case. And that ends the 2019 Section 1 higher paper.